Images contain a wealth of information that often goes unnoticed by the human eye. Computer vision allows us to decode this hidden language, revealing the fascinating patterns and trends with applications in areas like drone navigations, entertainment, and more. But you have ever wondered how a machine can actually understand the movement with all its complexity? That is the challenge that drove me to develop this project, to learn the potential of analyze the movement of players in a football match. This project immersed me in the fascinating world of computer vision, where machines learn to see and interpret the world around them. Imagine a system that can track a player's trajectory in real time, analyzing the performance. To achieve this, I dive into tools like YOLO, which enables the precise object detection, and OpenCV, which opened the door to low-level image processing. This to go beyond simply detecting players is needed to differentiate the players from the referees and the ball. This is where a fine-tuned YOLO model with a custom dataset from RoboFlow enters to the game to make things easier. The next step was enable the algorithm to follow the players across the frames, like the machine had its own eyes. And this is where ByTrack came into the play, an algorithm that assigns a unique ID to each player, allowing the system to understand the individual movements of each player. The algorithm was taught to recognize the jersey colors using k-means clustering, enabling the algorithm to assign players to their respective teams. And the real challenge lay in analyzing movement in detail. The camera is constantly moving, which distorts our perception of player movement. To counteract this, was implement an optical flow algorithm that estimates a camera motion in each frame. And to ensure truly accurate measurements, it was applied perspective transformation, which corrects for camera distortion and allows us to measure the player movements in meters, as if viewed from an aerial perspective. And finally, with all these elements in place, the system the system could calculate the speed and the distance covered by each player, providing valuable insights for the performance analysis. The resulting system can track every player on the field, estimate the speed and the distance covered by each player, and even determine which player has a possession of the ball at any given moment. And beyond the concrete results, this project has given me a deep understanding of the challenge and possibilities of computer vision, and has fueled my desire to further develop my skills in this field. Now I am looking to continue learning within a team that shares my passion for computer vision. The expansion of this project is explore the use of embeddings to automatically assign the players to the teams, implement key point detection to create a video game like radar view, and have the ball movement statistics and generate visual diagrams of the ball control for each team, highlighting where on the field they had the most influence. If you are interested like me in this world of computer vision, I invite you to DM me to the through the chat of LinkedIn. Thank you very much.